Hello. Today we discussing if you need the antennas for temporary use, just for function test only. It is happen quite often to RF test and measurement, especially when you work on the field. For example, when I worked for one of the telco project, when we set up the toy cell or the toy base station in customer's equipment room, we need to do some of function test. To test is the toy cell configured correctly, if the backhaul is it set up successfully. All this a lot, and then some other tests, even the core network, sometimes they need our toy cell to work for the test. So, but we don't have the proper antenna to connect to this connector. You see, this connector is quite big one. It's a DIN type connector. Normally the portable antenna is either N type or SMA type. So in this case, we need a temporary workaround solution. What I did, actually not just for one project, many of the projects I supported, we just cut a wire, because the wire is very easy to get in the equipment room. Cut the wire the 1/4 of wavelength and then plug into the center here. Then you can use it as a temporary antenna. Then you can conduct your function test. And also sometimes for when we use, for example, spectrum analyzer at the field, and then we may don't have the antenna, or the antenna is broken, but we need a temporary one. So in this case, we also can use a wire to connect to the input port of the spectrum analyzer, and then just roughly cut the wire 1/4 length of the wavelength. Then you can do the test. Let's see some of the real cases I conducted before. Here is the setup for our discussion today. We use a spectrum analyzer. This is a JDSU1 JD745A. It's a quite old one, because this one I did in 2017. Yeah, 2017. And then actually, what I did at the time, I used 3 types of wire. One is 1/4 wavelength, half wavelength, and also 1/8 of wavelength. But I didn't record the result for 1/8 of wavelength. But I remember the result is close to a half wavelength. So you look at the wire I prepared here. This one is 1/4 wavelength, and this is a half wavelength. And there's one test I didn't conduct is if you guys have the equipment and you can do it, maybe you can try to have a wire something like this. This is 1/4 wavelength here, and the other end also 1/4 wavelength, and then in the center you can plug this to the input port of the test equipment. See, the result should be better than just use 1/4 wavelength wire. And to compare, the antenna we use is a magnetic antenna with 0 dB gain. And to use this antenna correctly, actually we should put this one on a big plate, a metal plate. So this one actually is act like a deeper antenna. But anyway, we just put on table. It still work fine, because we're not going to just get the best result of this antenna. We just to compare this with the wires. Let's see the real test result. So if we use the antenna, the magnetic antenna, we see the channel power. It's minus 45.6 dBm. By the way, this frequency we test is at the 950 MHz band. It's a LTE frequency band, and in the bandwidth of this channel is 5 MHz. So the channel power we measure is in 5 megahertz, which is minus 45.6 dBm. By the way, we are not going to discuss the details of occupied power, integrated power, occupied bandwidth. These are the terminologies used in LTE interface. So if you guys interested, we can discuss this one in a series of videos, include for 4G or even 5G. Let me know in the comments area. And then let's see if we replace this antenna with a wire. See what will happen. So if we use 1/4 wavelength of wire as antenna, we can see the channel power is minus 54 dBm compared to what we just measured 45.6, which is about 8.4 dB lower, which is understandable because this is actually it's not an antenna, it's just a wire to use it temporarily. But it's still good enough to pick up the signal of doing some of a function test. You can see the signal level actually is a bit more than 30 dB higher than the noise floor. And then if we use a half wavelength wire as antenna, what will happen? Is it will be better or it worse? Actually, it's worse. So you see, even we increase the length of the wire from 1/4 wavelength to half wavelength, the power actually measured in this bandwidth is 3.6 dB lower. Similarly, result I got when I use 1/8 of wavelength wire to use as a temporary antenna. And then in the next slide, I list some of the frequencies and the wavelengths. The calculation is a very simple one. We can calculate it from this formula. Here is a little bit misleading. The unit cm is for the wavelength lambda, not for frequency. The frequency's unit is megahertz. And then you may also heard a lot about the people talking about the use a paper clip as a TV antenna. This is a hot topic in US a few years back. You can find a lot of video on YouTube. There are people talking about the paper clip as a TV antenna. This video, the link I paste in the description area. You can watch it later. It's a little bit more longer than 3 minutes. And then the channel pick up over there. The frequency is around 500 to 600 megahertz, and 1/4 wavelength should be around here, around maybe 13 centimeter to 16 centimeter. Sorry, to 15 centimeter. So the paper clip they use is I saw them use it. It's a longer one, 16 centimeter. Then the bend a little bit to plug into the receive port. So yeah, the length is 4 in between here. So it's lucky. The paper clip they use is just for match the best length. Use a wire as an antenna. And then yeah, let's just talk about the temporary antenna to here. If you guys have any comments, please leave it after watching this video. If you like the video, please like and subscribe and share. Thank you.